Hi everyone, welcome to another practice problem walkthrough video by physacademy.com. In this video, we will cover a relatively complex resistive circuit. The goal is to practice Ohm's law and load balancing technique. Let's read the problem statement and work through it together. The current in R5, the 8 ohms resistor in the drawing is 0.5 amps. Find the current in R7, R0, R1, and R8 resistors. Find the voltage drop between points G and F, A and B, A and E, and E and C. Before answering the questions, I would like to take a second to share some very helpful techniques for analyzing complicated circuits like this. I always start from the power source, let's call it a battery. The longer side of the symbol of a battery, or, in more professional terms, a DC power source, is the positive side where the battery shoots the electric current out. I highlight these sections in red as red is the standard for the positive side of a battery. I keep tracing and highlighting the connection until I hit a resistor or an energy consumer. Then, I go back to the negative side of the battery, and with a blue color, I again track and sketch the connections. Blue is the standard color of the negative side of a battery, where a battery collects the incoming current. Then, I highlight the connections between the resistors with different colors, so by looking at the colors, I can clearly say how many and what the electric potential zones are. As you see here, we have 5 electric potential or volt zones here in this example. By just checking the volt zones, we can say that points B, F, and G all have the same electric potential because they are in the blue zone. Let's focus on part A. So far, we know 0.5 amperes go through our 5 with 8 ohms resistance. Using the load balancing method, if 0.5 amperes goes through 8 ohms, then 0.25 amperes should go through 16 ohms. We know the currents of these two branches merge back, so the output current of this little section of the circuit is 0.75 amperes. Now that we know the resistances and currents, we can calculate the voltage drop across these two resistors using Ohm's law. In this case, the voltage drop from left to right is 8 times 0.5, which is 4 volts. Focusing on R7, we know I7 is 0.75 amps. Using Ohm's law we can calculate the voltage drop across R7 as 15 volts. Let's summarize so far what we know. Assuming the negative side of the battery is at 0 volts or 0 electric potential, we know B, F, and G are at 0 volts. So, right away, we can answer this part of the question. Both G and F are in the same voltage zone, so the voltage difference or drop between them is just 0. We know 0.75 amperes go through R7. The voltage drop across R7 is 15 volts, so the voltage at C or the yellow zone is 15 volts. The voltage drop across R5 and 6 is the same, and it is 4 volts, so the whole purple zone, including point D, is at 19 volts. Focusing on the bottom branch, where R8 and 9 are, we can see both resistors are between 19 to 0 voltage zones. We can use Ohm's law to calculate I8 as 19 divided by 9 or 2.111 amps. The same process for R9 gives us 19 divided by 19 or 1 amp. These two currents, 2.111 amps and 1 amp, gives us the total current of this branch, which is 3.111 amps. Let's update our answer sheet for the current in R8. Next we will focus on finding the current of R1 and the voltage of the green zone or point E. Now let's only focus on the top branch. To calculate the current in R1, first, we need to find the total current of this branch. We know the whole branch is between 19 volts of voltage drop. Using 2 parallel and then 1 series resistors equations, we know the whole resistance of the top branch is 4.089 ohms. Using Ohm's law, the total current of this branch is 19 divided by 4.089, which is 4.65 amps. Now that we know the total current of this branch, using the load balancing method, we see that 5 divided by 14 out of this 4.65 amps or 1.661 amps go through R1. Now that we know R1 current as 1.661 amps, using Ohm's law, we can find the voltage drop across it, which is 1.661 times 9 or 14.946 volts. Since the voltage of the purple zone is 19, and the voltage drop across R1 is 14.964 volts, we can see that point E's voltage is 19 minus 14.964, which is 4.053 volts. Alright, let's go back and update our answers. We just calculated the current passes through R1 as 4.65 amps. And also, now that we know the voltage of E, we can find the voltage difference between C and E as 10.947 volts. Next we are going to focus on R0 current and finding the voltage at point A. Now let's see what the total current of the purple region is. We know the current of the top branch is 4.65 amps, the current of the middle branch is 0.75 amps, and the current of the bottom branch is 3.111 amps, so the total current using Krichof's law is 8.511 amps. This is the same as the current of R0. Using Ohm's law, we get 102.132 volts across R1. And it means the voltage of point A is 102.132 volts plus 19, which is 121.132 volts. Alright, it seems we have everything we need, let's go back to the answer sheet and update it. We just calculated that I0 is 8.511 amps. And then delta VAB will be 121.132 volts. And delta VAE will be 121.132 volts minus 4.053, which is 117.079 volts. Well, that is it. We found all of the variables we were asked to. Thank you very much for watching this video. Please check our website, physacademy.com, or our YouTube channel for more practice problems. If you found it helpful, to support our work, please consider subscribing to our channel.